As mentioned in the previous tutorial on how to find quartiles in Excel, I mentioned that there is no one agreed upon approach to find quartiles. Instead, I've seen at least 8 different algorithms that have been suggested by statisticians, and Excel uses 2 of these algorithms. What I will do in this tutorial is explain what those 2 algorithms are. To begin with, using a hypothetical example, I will go through step by step the 2 algorithms that Excel uses in its quartile functions. Beginning with the Quartile.INC function in Excel, it uses what's referred to as an n-1 based algorithm, where n refers to the number of cases of the sample size in a particular example. In essence, one way to think about how quartiles are found in Excel is to imagine that we in essence have a ruler, and this ruler you see here has 11 inches in it, and that 11 inches comes from the example which I will use will actually have 12 cases. So 12 minus 1 is 11, beginning with the number 0 all the way up through to 11 equally spaced out inches. So we order our 12 cases from low to high, and we place the very first case, its value, at 0. And in this case, one case had a value of 0. The second case now goes at the 1-inch line, 7. The third case goes at the 2-inch line, and that's a value of 9, all the way up through to the very last case has a value of 42. And it then goes to the 11-inch demarcation we see here on our hypothetical ruler. So what we've done here now is ranked ordered the cases from low to high, and we've evenly spread them out. Excel then treats the quartiles as though they're percentiles. So the second quartile would represent then the 50th percentile. And that 50th percentile then would fall halfway or right in the middle of our ruler. So we take 0.5, representing the 50th percentile, multiply it by 11, the number of inches in our ruler, and we find then that the position on our ruler of the second quartile would be at 5.5 inches. And so we can mark the place on this ruler of the second quartile. Then to find the location of where the first quartile would fall, the first quartile in essence would be the first quarter or halfway between 0 and the second quartile. And in that case, it'd be the 25th percentile. So we take 0.25 and multiply it by the 11 inches. And we would then, counting from the beginning at 0, would then indicate or would suggest that our first quartile would fall at 2.75 inches. And so we can indicate on our ruler where that first quartile value would fall. Using the same process, we then can refer to the third quartile as being the 75th percentile, and that would then represent 3/4 of the way from 0 up to 11. So we multiply 0.75 by the entire length of 11 inches, and that indicates then that the position of the placement then of the third quartile would fall at 8.25 inches on this ruler. Now what these arrows indicate then is not what the values of the quartiles are, but where their location would be on this 11-inch scale. So the next task would be to identify what values are associated with these places along our ruler. We see that there is no value associated in our data with the second quartile because it falls between 2 values that do occur, 17 and 20. So what we need to do then is interpolate between 17 and 20 to find what the value of this median or the second quartile would be. Since it is at place or location 5.5, it's halfway between 17 and 20, so we find the difference between 17 and 20, which is 3, multiply it by 0.5 because we're halfway between the two, and that is a value of 1.5, and we add that then to the lower value between those two of 17. So 17 plus 1.5 will equal 18.5. So we can now identify that the value of the second quartile is 18.5. Now to find the value of the first quartile. We notice that, again, the first quartile is not associated with a value that actually exists in our data. Instead, it falls between the values of 9 and 10, the third and fourth cases in order, if you will. Well, we find the difference between those two cases, which is a value of 1 difference. 10 is 1 more than 9. And we see, though, that the first quartile is 3/4 of the distance between 2 and 3. 3/4 of a distance of 1 is 0.75. So we add that 0.75 to the lower value between this pair of numbers, and that would then be a value of 9.75. So we see here then 9.75 would be the value of the first quartile. Now we do the same thing with the third quartile. Again, there is no case that falls at position 8.25 on our ruler. Instead, we have values of 24 and 26 that fall on either sides of that position of 8.25 on the ruler. So what we do is we find the difference between, or the distance between 24 and 26, which is 2. We multiply that by 0.25 because we see that our third quartile is 1/4 of the way between 8 and 9. So 1/4 times 2 would be a value of 0.5. We add 0.5 to the lower value, which is 24. So the third quartile value is 24.5. And these are indeed the quartile values that Excel returns when we use the Quartile.INC function. Now the Quartile.EXC function in Excel uses a similar process as we just saw with the Quartile.INC function. However, it differs in terms of the length of the ruler, in essence, that it uses in order to spread out the cases we have for our data. And the length of the ruler then is determined what's referred to as the n+1 base algorithm. In essence, what it does is it takes the sample size, adds 1 to it, and then that determines the length of our ruler. So we'll have 12 cases in our example. We add 12 plus 1, that's 13. So in that case, our ruler goes from 0 to 13 inches. The cases in our sample then are rank ordered from low to high, and the very first case then, that value is put at the 1 inch mark on our ruler. The second case, which has a value of 7, is put at the 2nd inch mark, all the way up through to the last, which is the 12th case, which then is placed at the 12th inch mark on our ruler. And all these cases then are evenly spread apart. They're 1 inch apart, if you will. To find the location on our ruler of the second quartile, the second quartile is referred to as the 50th percentile. So we take 0.5 and multiply it by the length of this ruler, which is 13. And then that returns a value of 6.5. So the location of the second quartile would fall right in the middle of our 13-inch ruler here, or at position 6.5 inches. Now we do follow the same sort of logic to find the position of the first quartile. Now to find then the position or the place where the first quartile would fall, recall that Excel regards quartiles as though they're percentiles. So the first quartile would be the same thing as the 25th percentile. So it would fall 1/4 or 0.25 of the way between 0 and 13. So we multiply 13 and we get the length of our ruler, 13 from the n+1 based algorithm, 13 times 0.25, and we end up then with a value of 3.25. So the first quartile would fall at 3.25 or 3¼ inches on our ruler. To find the position or place where the third quartile would fall, we regard the third quartile as the 75th percentile. So it would be 3/4 or 0.75 proportion of the distance between 0 and 13. So we take 0.75 times 13 and we get a value of 9.75. So the third quartile would fall at inch 9.75 on our 13-inch ruler. Now keep in mind that what we see here, Q1, Q2, and Q3 on the ruler are not the values of those quartiles, but instead they're the positions of the place where those quartiles would fall if they existed in our data. Now the next step in the process is to find what the values are associated with those positions on our 13-inch ruler. Because there is no case that falls at inch 6.5, what we need to do is interpolate between 17 and 20 the cases that fall just below or just above at inches 6 and 7. So we find the difference between 17 and 20, and that's a 3-point difference, whatever units the variable is measured in. We then, because the quartile is halfway between these two cases, we take that 3 times 0.5, and that's a value of 1.5, and then add that 1.5 to the lower value of these two pairs of cases of 17, and that then gives us a value of 18.5 for the second quartile. So half of our data fall below 18.5, half fall above a value of 18.5. We'll do the same thing for the first quartile. Again, the first quartile doesn't actually exist in our data. Instead, the first quartile falls 1/4 of the way between cases that have a value of 9 and 10. The difference between 9 and 10 is 1 point or 1 unit. We take that 1 unit and multiply by 0.25, so we're going to cover 1/4 of that distance, and we add that then to the lower value of this pair of numbers of 9, which gives us a value of 9.25 for the first quartile. So 25% of our cases in our data fall below a value of 9.25. Following the same process for the third quartile, we see the third quartile does not exist as a case in our data. Instead, it falls between values of 24 and 26 that are located at inches 9 and 10 on our ruler. So we ask ourselves, what is the difference between these two cases? 26 minus 24 is a difference of 2 units or 2 points, whatever this variable is measured in. We see that the third quartile is 3/4 of the way between 9 and 10. So we multiply 0.75 by this difference of 2, which is a value of 1.5, and we add that 1.5 to the lower value of the two pairs of numbers that we see in our data of 24. And these are exactly the same values that are returned using the Quartile.INC or the Quartile.EXC functions in Excel. As you see, the case values that I have here in column A and the first, second, and third quartiles that are listed using each one of these two functions in Excel. Now, they will always agree in terms of what the median or the second quartile value is. They both indicate it's 18.5, but you'll notice that the Quartile.INC function returns a value for the first quartile that is higher than the Quartile.EXC and a value for the third quartile that is lower than the value returned by the Quartile.EXC function. So you always then will find that if there's a difference between the first and third quartile generated by these two functions in Excel, the Quartile.INC will generate a smaller difference or a smaller interquartile range than will the Quartile.EXC. Now the question then is, which one should we report? Well, what I can tell you is I'm not aware of any statistics package that uses the Quartile.INC function. And actually, this is a holdover from an earlier quartile function that Excel has. The Quartile.EXC was added to Excel a couple of versions ago. And there are several stat packages that use this exact same algorithm. So the algorithm that's used for the Quartile.EXC function is much more common. It is used by other stat packages, while the INC version of the quartile function is not used by other stat packages. So SPSS, for example, does generate the exact same Quartile.EXC values that we have here. So it uses the similar algorithm. So my preference would be to always report the Quartile.EXC results. Hopefully now that we've gone through that first example, you have a really good idea as to what are the algorithms that Excel has at the basis of both of its quartile functions. But that example didn't give us a really good idea as to maybe what the INC and the EXC actually refers to in each of the names of those functions. And what I want to do here in this example is show you that one way to think about the INC and the EXC is that it indicates the extent to which, or whether or not I should say, the median is used for computing then the values for the first and the third quartile. To illustrate the role of the median, what I've done here is I've reduced the number of cases from 12 down to 11, and I think with an odd number of cases it's easier to see the way in which, or the role that the median plays in finding the first and third quartile. I also have changed a couple of values just to make the process a little clearer. So what I've done here then is I've already given you the first, second, and third quartile values, that 9.5, 17, and 25.5 respectively, and this is using the Quartile.INC version. And what I suggested, one way in which we can think about then what the INC refers to, is that once we find what the median value is, then that median value is part of the data that's used to find what the first and also what the third quartile values are. And I'll show you in the next slide what I mean by that. Once we find what the median is, the second quartile, we can then turn our attention to the first quartile. And we think about a value of 9.5, and we think about the first quartile as being, in essence, the median of the lower half of the data distribution that you have. If we think about this, then 9.5 represents the median value if we include the second quartile. Additionally, we can see then that the third quartile, its value is 25.5, which is given to us by the Quartile.INC function in Excel. That it represents then the median value if we take into consideration all the values from the median, including the median, up through to the very last case, of value of 42. And this is what I mean then by the notion of the median is included in finding the values of the first and the third quartile. The first and the third quartile represents the median of the lower half or the upper half of the distribution, when it includes then, each of those includes the median value. Now when we use the exact same data with the Quartile.EXC function, what we'll see returned is again a median of 17, or the second quartile, which is the same regardless of the function that we use, but the first and third quartile values are now different. The first quartile value is 9, and the third quartile value is now 27. If we see or refer to the first quartile as the median of the lower portion of our data distribution, you notice it does represent the median only if we look at the lower 5 values of our data. And in that case, if we exclude the median from finding then the first quartile. Similarly, if we ignore the data point that is the second quartile, then we'll see that the third quartile that's generated by the Quartile.EXC function represents the median of the upper 5 data points in our data distribution. And I think this is the best way of understanding what the INC and the EXC functions, what those letters actually refer to when we think about understanding the algorithms underlying both of these functions in Excel.